In the world of relational databases, we have foreign keys which we can take advantage of via table unions and joins and things like that. Not so in a NoSQL database. The main reason for this is that a join would be too expensive or too time-consuming when using a large cluster of servers. So since we can't use joins and foreign keys in the way that we do in a relational database, this means that we have to change a few of our views on database normalization when we work with a NoSQL database like MongoDB. As you probably know, normalization refers to the process of organizing your data to minimize redundancy and dependency. If you've studied normalization much, you know that having your database tables in third normal form is exactly what you need to do this. However, when using MongoDB, it's actually much more efficient, technically speaking, to denormalize your database to certain degrees. In some cases, this kind of thing is very convenient. Let's do a find on all of our links, and we are just going to, again, run for each on print.json so that we can get a better view of them. Notice here that we did not use a normalized method of storing our tag names in these bookmark documents. We stored them in arrays. This is a good example of a perfect place to do this kind of normalization, mainly because the chance of us wanting to remove a certain tag from all documents in our system or rename a given tag is pretty unlikely. Of course, doing this would still be possible, but it would be much more expensive because instead of just going to a tags table and deleting a single record, and then going to our links tags table and deleting all the records that had that given tag in it, we would have to come here to our links collection and go through every single link to find the ones that had tutorials in it, for example, and then go ahead and remove that tutorials tag from each one of those. It's pretty unlikely that we're going to want to do this kind of maintenance with something as simple as a string tag name, so that's why this type of denormalization makes sense. Now, sometimes you may even want to do more advanced forms of normalization. Here, for example, I have a meta object, which is a subdocument within our main links document. This is the kind of information that in a relational database would also be stored in a different table. Another good example might be if we had a specific user that created this document. In some cases, it may even be desirable to have a user subobject and have the user's name and some other information about the user right within this links document. Now, if you're used to relational databases with properly denormalized tables, that's going to sound terrifying to you. But the truth is that it may be more desirable in MongoDB if it speeds up your queries. We'll talk more about how this works in just a second. But for right now, let's talk about a case where we may want to have a normalization of relating different documents together via their IDs instead of just embedding data inside of a document. For example, let's say that we have a users table here, and I'm going to go ahead and insert a user that has a name of Andrew. Really simple document, but that is a document that tells us about a single user of this bookmarks application. So now let's say we're going to create another link document, but this link document is going to point to Andrew as the user that created this specific document. First, I want to get a reference to the Andrew document. So I'm going to call that A. I'll say var A equals db.users.find1, and I'm going to find the document with the name of Andrew. Now, this is some query syntax that we haven't talked about yet. We're going to be looking at this for a couple of videos starting in the next video. So now A here is the document, as you would expect, and A._ID is, of course, the ID for that document. Okay, so now let's go db.links.insert. Let's give this the title of psd_tuts+, and this is going to have a URL of course, http://psd.tutsplus.com. And now let's have the user ID. And this user ID is going to be a._ID. So now let's say db.links.find, and I'm going to take the second one. And as you can see here, this document got its own object ID, just like we would expect. But notice that the user ID is pointing to that same object ID instance that this user up here has as his _ID value. Now, assuming that we wanted to get this from the database, we can store the link here in a link object, just like that. And now I can say db.users.find1, where the _ID field is the same as the link .user ID field, just like that. And as you can see, it returns our user ID object like this. So basically, this is just a manual way of doing foreign keys in a relational database. You just have to get the ID from another object and plug that in as the exact value into a field in another object, and then you have to know about it, and we can't do joins or anything. We just have to run a first query to get one document, and then we run a second query to get the document that gives us the user that is related to the first link document that we created. Now, of course, this method could work for our array of tags as well. If we had a good reason for wanting to store our tags in their own collection, for example, maybe we want to include a count of how many different links have that same tag or allow searching by tags, that kind of thing, then we could store those tags in their own collection. And instead of having an array of tag strings, we could have an array of object IDs. Each object ID, of course, pointing to the tag that link has. So, of course, the important question to ask ourselves here is, when do we use denormalization and when do we use document ID linking? And this is a tricky question. And again, I think this is a good example of, as I said in the previous screencast, showing how customizable or unopinionated MongoDB is. A lot of this depends on how you're working with your database most of the time. For example, if you're mostly reading data from your database and you're not doing a whole lot of writing, then denormalizing that data as much as possible is a good idea because it's going to optimize the amount of time it takes to read data out of the database. For example, with our bookmarks here, of course, bookmarks isn't a good example because that is presumably a collection that will always be adding new bookmarks to. But for example, let's say we, for some reason, we're not doing a whole lot of changing to either the links data or the actual user data. Then instead of just plugging this user ID in here like this, we might have a sub-object similar to what we did here with the metadata here, and put all of the user's information right inside that one document. This way, whenever we get the document, we also get all of the data about the user, and we don't have to requery the database to get that. Now, of course, if we ever change any information about the user, this does mean we have to go find every single link document that has that user information and change it in potentially hundreds of documents. But remember, I said this type of embedding of documents, this denormalization, is good if you're not doing a lot of writes. Sure, if you're doing an occasional write, maybe you can put up with a little bit of a slower write to give you faster reading by only needing to do single queries. But if you're doing a lot of writing to the database, especially a lot of updating of data that's already been written to the database, that's when you want to have something a little bit closer to an actual normalized database. Now, as we saw with the tags, sometimes it makes sense just to put them in an array or a sub-object. There's really no reason at all these tags should be normalized into their own database. So I hope this little rant here has shown you that MongoDB wants you to think about it. There's no single convention to follow when you're using MongoDB. Think about how MongoDB is going to be working behind the scenes and do what's going to be the most optimal for your situation. And for a lot of applications, I'm going to guess it's going to be a little bit of a tightrope walk between completely denormalized and not denormalized at all. You're probably going to want to do some denormalizing and some linking. Now, in this screencast, we started to get into some query syntax when we're using the find one method here and passing this object here to that method. There's a lot that you can do with queries in MongoDB, so we're going to spend a couple of screencasts talking about that, and we're going to start that in the next screencast.